good morning. My name is Wes Purvis. I work for MIST Systems, Technical Marketing Engineer. And this session I'm going to talk about BLE, specifically BLE in the context of location, and go through some BLE deployment best practices. So pretty simple presentation, why BLE for location, and then go through deploying BLE. So first, let's just talk a little bit about BLE. What is BLE? It's Bluetooth Low Energy, introduced as part of the Bluetooth 4.0 specification in 2009. There's 3 advertising channels in the 2.4 gigahertz band. There's one below channel 1, one in between channel 1, channel 6, and one above channel 11. So it's operating within, in between Wi-Fi channels. It doesn't actually interfere with Wi-Fi, which is good. So it makes it a complementary technology to deploy along with Wi-Fi, and there's no worry of compromising your Wi-Fi network. And BLE has been, it's been adopted by both Apple and Google, kind of natively within iOS and Android as part of it's an engagement technology. So you can actually engage with an iOS device or an Android device natively, get a pop-up notification on your lock screen without having an app installed. So this is one reason why BLE is popular for location. So let's talk about why you might want to use BLE for location. But before we do that, we should probably understand Wi-Fi location, so we can understand how they're different. So I think Wi-Fi location has been around for a very long time. It's not new, and fundamentally the way you locate a client with Wi-Fi is the access point listens for the client and tries to determine a location based on how it hears the access point, or how it hears the client. So this is the AP receiving. So in a multiple AP environment, how do you locate a client? Well, so let's imagine our client is connected to an AP on channel 36, and our other 2 APs are on different channels. So if we're trying to locate in this environment, in this scenario, only the serving AP will be able to locate the client. It's pretty simple, because our APs are on different channels. So how do we overcome that, right? So there's a couple different ways to do it. So first is using off-channel scanning. So either using the client serving radio or a dedicated scanning radio to go off-channel and scan other channels. That's how clients get located with Wi-Fi. Optionally, you can synchronize your off-channel scanning, and this will improve location accuracy a bit. You get more robust location updates. So it's in the asynchronized scanning model. This is the most typical what you get. Built into it's natively built into most Wi-Fi systems, and the downside is it's slow and infrequent because the APs have to scan every single channel. They also have to serve their Wi-Fi clients. So location updates typically come in the frequency of minutes, which for a location network, some use cases may be good enough. Many use cases, it's not good enough. In the synchronized scanning use case, particularly with a dedicated scanning radio, so this is most commonly implemented with a third radio on the access point. You get more frequent location updates, typically in the neighborhood of 5 to 10 seconds, because you have a dedicated radio that's able to scan the channels. However, this comes at the cost of scale limitations, because as you synchronize your channels and you have, say, 3 or 4 APs all scanning channel 36 at the same time, only so many clients can transmit during that single dwell. So the location calculations are based on client traffic. The APs have to be able to hear the client, and only so much traffic can happen during that dwell. So it makes sense that you're limited in your scalability with that. So now let's look at BLE, and there's really 2 ways that BLE can handle location. We have, so if we look at the model B, that's the, visibility where the client is transmitting. That's exactly the Wi-Fi use case. It's exactly how Wi-Fi does location. The model A is the opposite of that. It's all the access points are transmitting. The client is listening and does some location calculations or passes data off to somebody else that does a location calculation. So, many vendors allow you to implement both. So it's not typically an either or scenario, which is good. So messed up the animation here. It should say, does this look familiar? This is basically how GPS operates in the context of, all the AP is transmitting at once. The client is listening. It's exactly how GPS works. It's very scalable, so it's for certain use cases it's useful. So why would you want? So why would you go with a BLE for a location network? It has it's low impact on your Wi-Fi network. You're not using airtime to make location calculations. You're not having to do off-channel scanning. You can deploy BLE kind of separately from Wi-Fi or as part of your Wi-Fi infrastructure. So it's very low impact. You get more frequent location updates. So in BLE, you can expect location updates in the neighborhood of 1 to 2 seconds. With Wi-Fi, you're kind of looking at 5 to 10 seconds best case. Now that may not sound like a big difference, but how far can I walk in 5 seconds? I can walk pretty far in 5 seconds. So if I'm using a real-time application, turn-by-turn directions, that turns out to be a pretty big deal. You can scale higher with BLE. You can support more clients because the infrastructure is broadcasting essentially a location message instead of the infrastructure having to locate every single client. So it kind of flips the paradigm and allows you to more accurately and more scalably locate clients. And also there's a lower device power requirement. And where this comes in is if you're doing some sort of asset visibility. So whether you integrate BLE into a ID badge or some sort of wearable that you give to somebody, it can be battery operated, last for a long time, and be relatively small, which is important if it's a wearable. So that's kind of why you may want to use BLE for location. So let's talk about deploying a BLE-based location network. So what are the different BLE-based location networks that you can deploy? There's a couple of them. First, and probably most common, but I think that's changing, is a battery beacon-powered network where you're placing these battery beacons every 20 feet, every 40 feet, depending on how much accuracy you need. These beacons are nice because they're super small, super lightweight, easy to place. They're inexpensive, but they're battery operated. And so they can be difficult to manage in that they're small and battery operated because the batteries will die. They may be listed to last several years, but depending on how frequently you set these things to chirp, they may not last that long. I got a customer many customers, but one customer in particular that transitioned off battery beacons because their typical maintenance cycle was to replace the beacons every year. It's a sports league, so at the beginning of every season. And but what they're finding is throughout the season they would lose beacons and they wouldn't know it. Whether these things were deployed outside, so they would die. You didn't have very good visibility into the beacons and the management of the beacons. So it made sense for them to transition to more of an infrastructure-based beacon design. And there's a couple options for that as well. Many access points out there either have a USB port that you can plug in a USB-powered beacon, which is a very easy way to get started with BLE-based networks. And the other is, from past couple years, many access points out there also have a BLE beacon built into the access point that you can turn on, and it's just there for you to use. And those work well and fine. And then kind of the next step of that is using some sort of antenna array. This is also similar in the Wi-Fi world as well. Using a purpose-built location solution to enable higher accuracy location. And that's kind of the realm in which we go. Again, the infrastructure advantages, you don't need batteries. You don't have to worry about managing hundreds or thousands of battery beacons. So it becomes really alternative, sought after alternative. So let's talk about some use cases.
Can you mix?
Yes, you can. The question was, can you mix battery beacons and infrastructure beacons? And yes, absolutely, you can. Usually, the way the typical reason that you would do that is some area where it's either difficult to pull an Ethernet cable, or somewhere after the fact where you need to augment your coverage. You can put in a beacon, and yeah, not a problem there. Okay, so use cases. The major use case that we see is wayfinding, indoor GPS. Whether it's wayfinding through a mall, wayfinding through a big box store, through a hospital, through a school. It's something that we see there's a desire to do, and I think wayfinding for BLE's best use case is wayfinding. The frequency of updates makes it really attractive to deploy, and wayfinding is well understood. It actually works very well if you deploy it. Other use cases include notifications for app wake up. So you have an app installed on your phone, there's a beacon broadcasting, and it wakes up the app for some sort of notification or proximity message. Personally, I think that these sound great in theory. I don't think that they're used terribly often. They are used, and they're much easier to deploy than, say, wayfinding. But people kind of get annoyed by these notifications, I find. So, in my opinion, usefulness of notifications is questionable. A use case that I find really interesting is kind of the Uber use case. Uber for help. On your phone, you're in a store, you're looking at beds or something, and you can't find an associate to help you. How many times have you gone into a store and tried to get somebody to help you? A lot of times it seems like nobody's there. So you open up your app, you say, hey, I need help. The app, using location, knows where you are and says, all right, you need help. I'm going to sends that request to an associate. The associate says, all right, I see that you need help. I accept your request. I'm coming to you, and here's how far away I am. Other use cases include real estate optimization, path optimization, in warehouses, in general business. So it turns out that in large enterprises, the most expensive, the largest expense is payroll, obviously paying employees. Second largest expense typically is real estate. It's really expensive to own or rent any sort of property. So being able to understand how well your real estate is being utilized is something that we're seeing quite a bit of traction with. Other use cases include asset visibility, so finding lost or misplaced devices, or lost or misplaced people. We have one customer a hospital who, so it's a psychiatric ward, so people wandering around and they don't necessarily know that they're not supposed to be wandering around. So the system, the patients are wearing a wearable. It's a bracelet, and so they walk and they enter somewhere that they're not supposed to be, what's that? No, they don't get shocked. No, the system locates where they are and actually locks the door, so they can't get out. And the way that happens is essentially, yeah, geofencing in the real world. Missed access points have an I/O port on the back of it and can interface with a Stanley door lock. So it's really the use cases for location are whatever you can come up with. The opportunities are endless. It just you have to realize that location will take a little bit of effort to deploy. Location, I think, is something that is becoming more widely deployed, but it is not something that is widely deployed. And I think the major reason is because location-based systems are not standalone. They have to interface with many different other systems. And that tends to be a tumbling block for many IT organizations. They're not, if you could do an entire location-based system self-contained, I think that we'd see a lot more uptick. But because if you want to deploy wayfinding, you need a mobile app. If you want to do real estate optimization, you need to use some sort of third-party app. That whole ecosystem is a hurdle. And I think it will get easier over time, but I see that this as the major stopper for a lot of people.
Has there ever been any talks about, getting into manufacturers, about how we could have almost like a passive location in the fact where you're just carrying your phone, and if you said, downloaded the app and you said, yes, I'm going to get notified, but you don't want to have it running at all points of time, where the phone itself is just working with the device instead of an app?
So question around, do you need an app? Is that, wait a couple slides, I'll get there.
Oh, that's
these next two slides, I apologize. I try to keep this vendor neutral, but I want to actually show what goes into deploying a location system. There happens to be missed terminology on here, so I apologize for that. So when you're deploying, so this is an engagement solution. So wayfinding. So obviously you need the access point or beaconing device, and you also need a location SDK. Typically that is built into the mobile app, but the location calculations happen with the location system. You need some sort of mapping and navigation. So you need to convert your floor plans into a vector floor plan, or add waypoints, that kind of stuff. And then you also need, typically there's a marketing piece as well. So you want to be able to do campaigning or content management. That's another SDK. And it's a whole ecosystem, right? So it's not, in this case, it's not just Mist that can do end-to-end location. You need many other pieces to make that happen. And then conversely for asset visibility, so various, you still need the APs, you need, but you also need the tags. And so these tags, whether they're iBeacon or some sort of other beacon, that you can, that has other information built into it, whether it's temperature monitoring. And so you have to integrate with these tag vendors as well. And then have some place to look at that location data, whether it's within our particular dashboard or your own dashboard. So it's a complicated system to make location work, and I think, which is why it's not terribly widely deployed right now. So back to Robert's question of, do you need an app for BLE location? Yes and no, depending on the use case. So I guess the answer is 42. So do you need an app? So for your best location, you need an app. So to do the GPS style location where the APs are transmitting, client is listening, and doing location calculations, you need an app for that. And that will really give you the best location. If you're doing indoor wayfinding that leverages that use case, you need an app. If you're doing proximity notification, it's optional. On both iOS and Android, you can notify to the lock screen without an app. It takes a little bit more effort. You have more flexibility if you do have an app. It's probably recommended to have an app, but it's not a requirement. And then for analytics or the passive visibility, you do not need an app. So whether it's your phone that's beaconing or some sort of wearable or other device that's beaconing, and the system can listen and track those.
So you can passively geofence.
You could passively geofence, but the problem with a phone is phones don't beacon very frequently. So you really do need some sort of dedicated beaconing device that you can ideally control the beaconing interval. Set somewhere twice a second, once a second is ideal. So let's talk about deploying BLE location. So for both wayfinding and asset visibility, you want to imagine a rubber band around the outside of your access points, and your best location will be within that rubber band. Outside of the rubber band, you'll get so-so results. So that's the first rule of deploying a location network with BLE. You want to stay within your rubber band, and I think it's pretty similar for Wi-Fi as well. You need to understand your flows and also the environment. So you need to understand where people are going to walk, especially if you're doing a wayfinding-based network. So understand where people walk, where they do not walk. Most importantly, you need to understand the building environment. So let's look at these 3 APs right here. Why would you deploy 3 APs in such close proximity? There's 3 APs probably with 20 feet right there. The reason is this is a hospital and there's fire doors there and there. So if you don't understand your environment, you may not see that. You may deploy 1 AP and you're going to have a really crappy location experience because those doors are kept closed.
So NIST is recommending you install APs in hallways?
So the question was, is
Wi-Fi AP or the BLE?
I'm talking for a location-based network, you need to have your BLE, in this case, in the hallway. Yes, absolutely. So it raises an interesting question. If BLE is built into your Wi-Fi access point, how do you juggle it? What is your priority? Is it Wi-Fi? Is it your location network? Can you do some sort of this particular customer? It's it's all in one. So I mean they have so many APs anyway that
But don't you guys have BLE? Aren't there all not just you guys, but aren't there also BLE APs as well?
Yes. So the question is the question is there a BLE only option? And from us, yes, there is a BLE only option. I'm talking just for wayfinding. Recommendation is to deploy, where the clients are, and for wayfinding, it's in the hallways. You'll see for asset visibility, that may not be the best deployment. Okay, so other environments. So rule of thumb is you want to deploy. This is best practices for Mist, but you can probably leverage these for other vendors as well. So for us, you want to deploy a BLE capable AP every 15 meters or so, and no more than a height of 15 meters. If you go higher than 15 meters, it can work. It may not work as well. What's that?
15 feet.
Sorry, yeah, a height of 15 feet, which is 4.5 meters. So here's 2 examples. One is a grocery store where the APs were deployed in every other aisle, and then also at the end of the aisle. So the customer wanted to be able to locate customers within the aisle, so aisle level accuracy. And so imagine our rubber band, we're staying within that rule. Second use case is in a mall. So when there's a question.
Yeah, what accuracy are we talking about here? When we take 15 meters, we put an AP?
Yeah, so the question is around what kind of accuracy can you expect? We typically say accuracy in the 1 to 3 meter range. It really just, there's a lot of factors that go into it. So wayfinding, if you deploy within these rules, very confident with 1 to 3 meters. But you also have to realize the use case. It's wayfinding. So if I'm walking, at some point my eyes take over, right? So I don't, I can navigate myself in the hallway. I need to know whether to turn left or right. That's the, that's the kind of use case. It's, there are other use cases where you want to know exactly where an object is. Those are a little bit more tricky. Question?
Yeah, are all those omnis or directional?
So the question is, are these omnidirectional or directional antennas? So this particular example, these are missed access points. They're directional. They have an antenna array built into them with 8 directional beams that come out of them. And then the mall use case, wayfinding in a mall, again, so you would put these in the hallways because that's where, in the passageways, that's where people walk. And also at the junction points for best visibility. So the junction point is another interesting interesting deployment, right? Because for Wi-Fi, you may not want to deploy in the junction point because it may cause roaming issues, because you can see in every direction. So sometimes you want to offset, from the junction, so that as you round the corner, then your client roams. Those are just kind of general guidances. There will always be corner cases. This is a hospital with a 6th floor open atrium, which made for some interesting challenges. It actually, we did get it working well, and the way that it happened is basically the way that we do location is we're listening for all the beams that come in on the client, and they get reported up to the cloud. And so it's the more signals that you hear from a particular floor, that's likely where the client is. So the answer in this particular use case was to put more APs on the bottom floor so that you could hear more APs on the bottom floor. So let's talk about the lower part of the atrium. So the atrium's open, right? So put it as low as you can in the atrium. Next up is asset visibility. So asset visibility is a completely different animal than wayfinding. And the deployment is dictated by the desired accuracy. So the 2 typical accuracies that we see that customers request are zone-based accuracy. So these, maybe, a quarter floor, half floor, like pretty, not very granular in terms of location accuracy. In this case, it's pretty easy. You can deploy 1 AP, a couple APs in a zone, so you get some sort of, location measurement going on. More accurate is kind of the room-based accuracy. So this is the use case where in a hospital, they have, pieces of equipment that get billed by their usage. And so knowing whether it's in the closet or a patient room, it turns out to be critical for billing needs. And so having that room level accuracy, you have to deploy more APs. So the recommendation here is to deploy an AP every 8 to 10 meters and in open areas, and then an AP in every room that you need location accuracy. So if, this example here is an office building with open offices, open floor plan, and then offices. So there's APs, over the desks, and then an AP in every conference room. I think this is 60 or 70,000 square feet. I don't know what that is in meters, I'm sorry. And there's like 80 something APs in that 60 or 70,000 square feet. So it's, to get that, if this is your requirement, you need a lot of APs to make it happen.
Divide by 10.
Okay. So how can you have success with a location deployment? So first, did you scale your floor plan? You'd be surprised. These are very common issues that we see. Floor plan not scaled. By the way, how am I doing on time? Close, okay, I'm almost done. So did you scale your floor plan? Did you place your APs on the floor plan? Did you orient your APs? So you may answer yes to those questions, but were your APs installed per your specification? And this is something that we see all the time, that APs are not installed to spec. So we typically recommend have your APs installed in the same orientation because it makes your life so much easier when you're doing a deployment. You can just, you can bulk edit and, orient your AP in the correct fashion. It's very frustrating when you have one AP that is slightly off from the rest and you have to actually walk through, as you're doing your validation, you walk through and you see, okay, this guy, in this case, it's off by 20 degrees. Which is enough to cause an issue. So it's, it's important to work with your installers to tell them first, install in the same orientation. And if for some reason you're not able to install in the same orientation, please note the deviation so that, can update in the system. Roaming, the Wi-Fi and cellular are also very important for location. So the way that the location gets calculated, APs are sending, or the clients are sending location data up to the cloud. And so if they don't have a stable connection, whether it's over Wi-Fi or cellular, it's going to lead to gaps in the location data, which leads to either the dot stuttering or the dot jumping. So that's not a great situation. So sticky clients are bad. If you have a really short captive portal timeout, that's bad. We've seen that. If you're roaming between different infrastructures, so we have customers that are, they have new construction, so they put in Mist, Wi-Fi and BLE, and then the old infrastructure, they just put in a BLE infrastructure on, with their existing Wi-Fi. So being able to roam between those infrastructures is important. There are ways to deal with this. So gaps in connectivity can be kind of smoothed out by something that's called dead reckoning. So this is using the sensors within the phone itself to, using the compass and the accelerometer to realize, okay, I'm walking, my dot is stopped, but the phone knows I'm still walking. So using dead reckoning, using offline information to make the location calculation. Tools that you use for location deployment. You can do pretty much every location deployment and validation with two tools. One is a laser distance measure to be able to figure out where your APs are. The second is a compass to be able to figure out which orientation your AP is pointing if you're inside a building. So this, I'll rush through this, which is, if I can find my mouse. So if all goes well, this is what indoor wayfinding can look like. So this is at the Swan and Dolphin Resort, Disney Resort in Florida in the US. So navigating to the business center. So you should expect a smooth dot that updates frequently and follows you as you go around a turn. What you're looking at on the right is in our system with the location calculations that are happening. So a small tight dot is good. We have high confidence where the client is located. If you could actually see the squares, which are the APs, you'd be able to see the individual RSSIs that our APs that the client is hearing from our AP. And then on the right side was the actual location data that was coming in, how many beams and that kind of stuff. So this stuff can work. Location networks are real. They just take a little bit more effort than a Wi-Fi network. BLE is a good choice for location networks, in my opinion. And your design will be based on your use case. So formulate a plan of attack, formulate a use case, figure out vendors and an ecosystem that you need to work within, and you'll have a reasonably high chance of success with a location network. Thank you.